Okay, assalamu alaikum, Shema. Welcome back to the class. Today we are going to have your quiz, which is going to be a 15 minutes quiz, and you will have 5 minutes to upload your solution. Of course, the quiz is similar to other quizzes. You can supply, by writing your final answer. If that final answer is correct, you should get the full mark. If that final answer is not correct, it will show up for you as a 0. But when I mark your submitted solution, I will give you partial credit. Okay? So let's get into the class today. There is one important announcement I would like to make, ya shabab, which is I need your attention over here. It's a little bit confusing. Because do you know that Sunday, next class, next week, we are not going to have a lecture. You will have on Sunday, you have a lecture substituting a normal Wednesday. And on Monday, we will have a lecture substituting a normal Thursday, which means our regular lecture will be on next Monday. You understand? Next week. I mean, we will still have another lecture this week, which is on Thursday. But the week after, we will not have a lecture on Sunday. We will have a lecture on Monday. Do you understand that?
So is it at the same time? Because we have another
everything is the same. خلاص خلينا نتكلم بالعربي. يوم الأحد القادم بيكون تعويض عن يوم أربعاء. ويوم الاثنين القادم بيكون تعويض عن يوم خميس. يوم الخميس بالنسبة لنا مثل اليوم عندنا محاضرة من 10 إلى 11 لحق الماشين ديزاين، وعندنا محاضرة من 1 إلى من 12 إلى 1 حق الأذر سكشن. But it's Saturday Sunday الأسبوع القادم there will be no lecture. Now, this is what is important. Today, within the next 27 minutes, I will try to finish the last section of this chapter. Okay? Now, what do we need to do? We have 2 lectures. We need to use the lectures for your project presentation. Now, I guess, if I tell you that I want you to do the presentation on Thursday, all of you will jump on me and say, no, you didn't tell us before. Why I don't want to do it? Why do I want to do it on Thursday? I wish I can do it on Thursday. Because if we do the project presentation and we finish it, we will have the other lecture, which is the last lecture. I am going to talk in general about chapter 9. But chapter 9 will not be included in the final exam. But we want to give you the idea of chapter 9. But if, for example, Thursday, I decided to give you the idea about chapter 9, then we will have only 1 lecture for the project presentation. And I am afraid that 1 lecture will not be enough. I can't ask you to come after class ended. So this is the dilemma I am in. But we will talk about it maybe later or by email or something. Okay? I need now to finish this material to make sure that you understand it very well. This is very important material. You should even expect in the final exam that you will have a problem about this section. Okay? So what is it? It is about bolting joints. Okay? So we have a bolt in a simple way for, let's say, a blade like this. Let's say this is the wall. And if this is the wall, and then you use a bolt, which are this one, this one, this one. And then what did you do? For another reason, there is a load like this. Now, what will happen is very simple. Let me tell you what will happen. Okay? Just bear with me. There is a little hint which is very important. If you understand it, خلاص خلصنا. That's it. ترى هذا section has one single equation which is new. The rest is very simple. So what is happening? Let me draw this again. This is now the plate. And this is bolt number 1, 2, and 3, and 4. Okay? And don't forget that, sorry, the wall should be somewhere here. What do we have? We have a force applied here. This force, we will call it F. I'm trying to make it bold here to understand that this is a big F over here. Now, what is going to happen is the following. First thing, احنا interested on the bolt. We might be interested on what is going to happen to this member. That's fine. This member will be under bending, for example. If you consider that the member is fixed like this, and you apply load to it, and let's say you assume that this is a fixed end, you can imagine that the member might bend. صح ولا لا? So, one of the failure of this joint, البندing لحق هذا العمود. Another type of failure, for example, is maybe yielding. Why? Because if you cut this cross section, okay, with respect to the bending now, you have an I is not equal to 1 over 12 BH cube. Why? Because this H is not complete, blade is not a complete cross section. It has hole. So you need to take the holes out. But everything here is just bending, just exactly what we did before. Now, if we want to know what will happen to the bolt, which is something very new to us, then it is fair, ya shabab, to say that over here, I need this to be very corrected about anything. So if we think about the bolt, ya shabab, what do you think this force F is going to do on the bolt? Any suggestion? شو اللي بتسوي؟ يعني خلونا نتكلم عن equilibrium forces whatever. الاف هذا اللي باللون الاحمر وش بتسوي على البولت؟ anybody يا شباب؟ anyone؟ مشغولين تذاكرون حق الكويز صح؟ ما عندكم وقت تذاكرون الا الحين. Well, if nobody wants to answer, I have no choice except to answer myself. Well, what will happen to the force, ya shabab, is that this F is going to be divided into 3 forces. This is 1, this is 2, this is 3, this is 4. That's equilibrium. I have reaction, which are, it's logical to say that each bolt will carry 1/4 of the force. So what is the action of these yellow forces? These yellow forces are shearing the bolts off. So ليه يا شباب؟ لأنه from the side, this is the plate, this is the wall, okay? The force F is acting there in the back, and the bolts are here. These are the bolts. So when the F is divided as yellow forces, they are actually trying to shear off the bolt. So we will call this one a direct shear, and we will name it F prime. And this one F prime, and this one F prime, and this one F prime. Now, in order to understand things and we talk in a clear way, I am going to call this one bolt number 1. This is bolt number 2. This is bolt number 3. This is bolt number 4. For that reason, I'm gonna call this one F prime 1, F prime 1, F prime 2, F prime 3, and F prime 4. Now, what is F prime 1, F prime 2? This F prime 1 is equal to F prime 2, which is equal to F prime 3, which is equals to F prime 4, which is equal to the red force F divided by 4. If I have 5 bolts, I will divide by 5. If I have 6, I will divide by 6. If I have 3, I will divide by 3. If I have 2, I will divide by 2. I forget to turn on my webcam, by the way. Good, ya shabab, if you are listening. Now, there is another thing which is going to happen, which is the fact that this force is shifted from the bolts. And in order to make things easy for us, we're not going to treat each bolt alone in the beginning. Let's just think of this as an entire joint. If we think of those 4 bolts as entire joint, then we can fairly say that by geometry, if this is a symmetric joint, the diagonal over here is going to represent the center or the centroid of the joint. And thus, ya shabab, if I take the distance, this distance, if I call it, let's call it D or you know what? No, not D. Let me call it X. If I take this X as a distance and I have a force, then if I want to know what will happen to the bolt, there is another load, mechanical load, which will be applied in addition to the yellow one. This mechanical load is M. And M is acting like this. Now, this is the story. What is this M? What is it? If you think about it, M here, when you look at the bolt, it's not bending them. It's not. Don't you think? If this is the bolt, and I am applying a moment, I am bending the bolt like this. That's fair, that's bending. But if this is the bolt, and I am applying a moment like this, I am not bending it. The truth is that the physical geometry of the problem indicate that this moment is actually going to shear off the bolt like this. Do you understand? It will shear it off like this. So what will happen is the following. If we think about, this is bolts 1, 2, and 3, and 4, and now they are subjected to F prime 1, F prime 2, F prime 3, and this one is F prime 4. The moment, ya shabab, look, the moment will be converted into a sheer couple of forces. How is that? Look, the moment was in red. Am I right? I wrote the moment in red. So what will happen? This moment will be converted as F like this. لاحظوا, this F is perpendicular to the diagonal, and then another F like this, and another F like this, and another F like that. Now, this is a moment, but this moment is generating a couple of shear forces. These forces are trying to cut the bolt from the side. And in order, ya shabab, to distinguish between F prime, which is a primary shear, we call it, this one, we call it primary shear force. This one, we will call it secondary shear force. What is the secondary shear force? Look, we're gonna call it F double prime 1. And this one, F double prime 2. Why double prime? Because it's secondary. Why 2? Because it's at bolt 2. So this one is going to be F double prime 4, and this one is F double prime 3. Now, this is the question. I converted everything from F, the red one, back at the end into a local group of forces acting on the bolt. How can I assess the health of the bolt right now? Well, the next step is to do the following. In reality, ya shabab, there is an equation which is going to convert M into F double prime. And when we convert M into set or a group of forces, they are just going to be forces. So you can imagine that bolt number 2, this is bolt number 2, is subject to F prime 1, which is equal to F over 4. I know the magnitude. I know how much I am applying. I just need to divide it by the number of bolts. And if I have F like this, which is F double prime 2, then, ya shabab, this is so familiar, right? So familiar. Why? Because this is a vector. I can come, take this, and shift it down. Look, I'm going to shift it down here. Call it F prime 2, which is equals to F over 4. And now I have two vectors. Two vectors. So if you think about it, I can get the resultant. When I get the resultant, okay, I will have a resultant shear force. This F resultant is going to shear off the bolt. And if I can know what is the maximum shear, allowable shear, I can compare this F resultant with the allowable one. I know if it is safe or not. وخلاص خلصنا. Do you understand? That's it. That's your job. So, the question, how do we need, طبعا يا شباب, this is how the centroid, if you have multiple bolts, but I am telling you that we would never give you a problem where the centroid of the bolted joint is very difficult. We usually give you 3 bolts in a joint like this. We usually give you 4 bolts. We can give you a problem of 3 bolts, something like that. So where the centroid of the joint is not very difficult. Why? Because if you know the centroid of the joint, you will be able to get the moment and then convert that moment into secondary shear forces. That's the story. So how do we do that? This is the explanation of what I told you. And over here is the equation which tells you how to convert the moment into shear forces. So what is this equation? Look at it. It says that F double prime N, where N is the number of bolts, is equal to the moment multiplied by Rn. So what is Rn? If you are talking about N, I mean the index of the bolt. If you're talking about bolt number one, so for F1 double prime, you have M, the moment, which is the force multiplied by the X, the centroid. And then you have R for bolt number 1. What is R for bolt number 1? If the centroid is here and bolt number 1 is here, then this is R1. If bolt number 2 is here, then this is R2. If bolt number 3 is here, this is R3. If this is 4, then this is R4. Do you understand? Then after that, you divide by the square of the distance for all of the bolts. So if you have 4, you put the square of R1, R2, R3, and R4. If you have 3 bolts, you put the square of R1, R2, and R3. That's it. So, and then we will have these forces through the geometry, okay, being combined into a resultant force. So let me show you an example over here. This is example, I'm going to show it to you, and then we will solve one. Here, what do we have? If you look, this is the joint now. This one is a beam. And this one is like a plate. Okay? So as you see, the plate is bolted to the beam by A, B, and C. All dimensions are given to you. Why? Because you need this dimension to measure the distance from the force to the centroid. You need this. Not only this, by knowing the dimension, I mean, if you get it a square, you're lucky. If it is a rectangle, it's easy. Okay, it's easy. Why? Because you will go and find the centroid to be right here, and then you will have this one as RB. You have this one as RC, this one RD, and this one as RA. And in order to know these R's, you need to know what are the exact dimensions between these 2 bolts. I mean, these bolts are 4 bolts. So what happened is this. When we find, this is what's going to happen. Look carefully. This is the yellow over here. The yellow is basically F prime. You don't see it very well, right? So let me write it in blue. So this is F prime. This is F prime. This is F prime. And this is F prime. F prime is equals to F divided by 4 right away. What is the second one? It's the moment. This is the moment, right? If this is the moment, then that moment, طبعا يا شباب هو هنا حاط المومنت على السنترويد, and then in the bolts you will have a reaction. Okay, so what will happen? He got a perpendicular F double prime, perpendicular to this line, and then perpendicular to this line, this is F double prime, and then perpendicular to this line, this is F double prime, and then perpendicular to this line, this is F double prime. Then, as you see in blue over here, he got the resultant force. That's it. You get the resultant force, and then يا شباب أهم حاجة تعرفوها في المشكلة هذه شنو؟ Let me clean it up. The problem that we face over here, if you look, this is going down, this one is going down. So it is fairly to say that this force is gonna get an action of addition, while this one is going up, this one is going down. This one is going up, this is down. This one is going down, and this one is going down. So what will happen? In many, all the time, this is what we face. نكتشف يا شباب إنه there is either 1 or 2 bolts that are more dangerous than the others. يعني ال F resultant, the resultant force for bolt number 1 is something. The F resultant for bolt number 2 is something else. The resultant force for 3 is something. The resultant force for 4 is something else. One of them, and sometimes 2 of them, get a bigger share, so they become more dangerous. And for that, we ask you in the exam, which bolt is dangerous? Which one is the dangerous one? They are not going to be all the same. And sometimes we get like, for example, in here, I think these two bolts will be at risk. Okay. And sometimes you get one bolt at risk, the rest are fine, depending on the geometry. Do you understand? So what will happen over here? Of course, ya shabab, this is teaching you how to find the R. And then look, this is the primary shear, which is F/4. And now look at this one. I want you to understand this equation. This equation, which is F double prime. Now, because the bolts are distant as an equal space, then F double prime 1, F double prime 2, F double prime 3, F double prime 4 are all going to be the same. And what is going to be the equation? As I said, it is equals to the moment multiplied by the distance of the bolt, which is the same. All bolts are exactly at the same distance from the centroid, divided by what? R1 square plus R2 square plus R3 square plus R4 square. And because R1, R2, R3, R4 are exactly the same, they are equals to R. So R1 equals to R2 equals to R3 equals to R4, which is equal to R. Then we will have this one equals to M R divided by 4R square. 4R squares. So it is going to be equal to M divided by 4R. That's why. Do you understand that? Why? I cut this with the square and I have M over 4R. So when I get this, okay, I can then find the shear stress. If I get the resultant force, the most important thing here is the shear. This is a shear joint. So the most important part is the shear. So shear is equals to F resultant over the area. The question is, what is the area? What is the area? So in general, we have 2 minutes only before we start the quiz. If the shear joint is like this is now the wall, or this is the beam, and the bolt is right here, okay, then we need to do the analysis. What is the analysis? Here, this line is the shear line. نجي نسأل هنا سؤال. Is this AD? Is this AR? And that's the most important question. Do you understand? So if the shearing is happening at the thread, we should use AR. If the shearing is happening at the shank unthreaded portion, then we should use AD. Do you understand? And this is why you need to ask the question about the area, the shearing area. So what happened is that this is one mode of failure, which is shearing. The other mode is this. When you apply the load over here, okay, the bolt itself is going to be subjected to bearing load. Why? Because this area, the projected area of the bolt, is going to push on the bolt نفسه. So, do you remember what we did before? We have the bearing stress on the bolt, the bearing stress in the member, you have a bending of the member. All of these could be a possible failure modes, and that's why we can examine them. I think I reached to the end, and I have to give you the quiz. We can talk about this inshallah later.